Hey math kids, today we're going to talk about special number sets, and we're in section 2D in the book, and this section doesn't have any examples, but we're still going to talk about them. Now, in previous classes, the natural numbers were probably defined different. So the way that your book defines natural numbers is actually how other classes or other books might define the whole numbers. So it's all the counting numbers and 0. So 0, 1, 2, 3, 4, 5 goes all the way up to infinity. And that's just the natural numbers. I believe it's called that because they're the numbers that we typically start with. So if you have a younger brother or sister, they might know how to count to 5, 10, 15, whatever. But they generally aren't counting 1.2, 5.7, things like that. So those are the natural numbers. And it's just the counting numbers as well as 0. Okay, then from there we can move up to the integers. And the integers are the counting numbers, 0, as well as the negative versions of those numbers. So your book writes it a little bit different. So if you like how the book writes out the set, that's fine. You can use it that way. I like to write it out like this, though. So make sure you look in your book as well to see if it makes more sense to you. But once again, it's all the counting numbers, 0, as well as negative numbers. But we still don't have any decimals or fractions involved in that. Okay, now if we continue on, sometimes we only care about positive integers. And that's what in previous classes I would have taught as natural numbers. So it's the same as this new definition of natural numbers, but without 0. Because 0 is not positive or negative, and so if we're asking for positive numbers, we don't include 0. So this one is called positive integers. And essentially we take this set right here and we only write down the positive numbers, 1, 2, 3, 4, 5, etc. Okay. Now, the next one we want to talk about is the rational numbers. And rational numbers we can't write in this same form. And so, we can't do this, just list all the rational numbers. But it's any number that can be written as p divided by q, where p and q are contained on the set of all integers, with the exception of q cannot equal 0. So all this means we go all the way back up here to integers. We take any of these two numbers and divide them as long as 0 is not on the bottom, and that will create a rational number. So if we get something like 1 divided by 2, that's 1/2, that's a rational number. 5 divided by 3, that's a rational number. -2 divided by 5, that's also a rational number. Now if we try to do 1 divided by 0, that's not defined, and so it's not a rational number. Rational numbers actually show up in a few different ways. So they can show up as a fraction. And the set's called rational, by the way. Rational numbers. So they can show up as a fraction. We see that here. They can also show as a terminating decimal. Which all that means, it's a decimal that stops. So 1.5, 1.629, etc. They can also show up as a repeating decimal. So that would be like 1.66666 repeating, 1/3. can translate into 0.333. And the last, probably the most obvious, but maybe feels like we don't need to say it, but just a whole number or an integer, I guess we could say. So 1, 5, -2. All of those are also rational numbers. So the 4 ways, once again, if we see a fraction, if we see a whole number or a integer, a terminating decimal, meaning a decimal that stops, or a repeating decimal, which is one that follows a pattern and goes on forever. Okay? Now the next set is, the complement of this. So we write it as Q complement, because that was rational, but we pronounce it irrational. So irrational numbers. It's just any real number that cannot be written as a rational number. So our script Q. Some examples of this, we have pi, right? Because that's 3.1415, doesn't follow a pattern and goes on forever. We have a number phi that you may have come across in a class. E is another one. So we tend to have these special irrational constants that just show up, but also the square root of any number that's not a perfect square. So all of those will give us an irrational number as well. And the last set that we're going to talk about is script R, which is the set of all real numbers. And any number that can be placed on a number line is how they choose to define that. Any number that can be placed on a number line. Alright, that's everything I have for this video. If you need additional help, come to Math Lab, calculator.